The anglerfish. Picture the darkest place you have ever been. A room with no windows, no light from under the door, no glow from a phone screen. Now go deeper than that. Go so deep that the sun has never once touched the water around you, where the pressure would flatten your lungs before you could scream. That is where she waits. The female anglerfish hangs in the black water between 300 and 5,000 meters below the surface, perfectly still, carrying a single light on her forehead. That light is alive. It is produced by bacteria living inside her body, glowing just enough to pull curious creatures out of the dark and straight into her jaws. She does not chase. She does not need to. She simply glows, and the ocean brings her dinner. But the story gets stranger when you learn what happened to the male. He is a fraction of her size. She can be 500,000 times heavier than him. He spends his short life doing one thing: finding her. When he does, he bites into her body and does not let go. His skin begins to dissolve into hers. His eyes go. His fins go. His organs disappear one by one until nothing remains of him except his reproductive tissue, fused permanently into her body, kept alive by her blood. He becomes part of her. Scientists have found females carrying up to 8 males attached to them at once. And here is the detail that stays with you. 80% of female anglerfish never find a male at all. They spend decades in the dark alone, glowing for no one. The Goblin Shark! There are creatures that look like they belong to another time. The Goblin Shark is one of them. Its family line stretches back 125 million years, to an era when dinosaurs were still alive, and in all that time, it has barely changed. It grows to between 3 and 4 meters, sometimes more. One specimen pulled from the water in 2000 was estimated at around 6 meters. Its skin is translucent and flushed pink, because the blood vessels beneath it are visible through the surface. It looks in photographs less like a shark, and more like something assembled in the dark by something that had only heard a shark described. And then there is the jaw. In its resting state, the goblin shark's mouth sits tucked beneath its long, flat snout. But when prey is close, something happens that should not be possible at that size. The jaw launches forward, not opens, launches, projecting outward at 3.1 meters per second, covering up to 9.4% of the shark's total body length in approximately 322 milliseconds. Faster than your eye can register it, the jaw is already retracting with whatever it caught. No high-speed pursuit, no chase through open water. Just darkness, a long snout, and then nothing where the prey used to be. It finds that prey in complete darkness using electroreceptors packed into its snout, sensors so precise they detect the faint electric fields produced by living tissue. The goblin shark does not need to see you. It only needs to feel that you are there. The vampire squid. Its scientific name is Vampiroteuthis infernalis. That translates, without exaggeration, to vampire squid from hell. Scientists gave it that name because when they first pulled one from the deep water, they did not know what they were looking at. It is not a squid. It is not an octopus. It is the last surviving member of an order that has existed for approximately 165 million years. A living relic drifting through depths between 600 and 3,300 meters in parts of the ocean so starved of oxygen that almost nothing else can breathe there. The vampire squid does not just survive in that environment. It thrives in it because the predators that would eat it cannot follow it down. When something does threaten it, the response is theatrical in the most unsettling way. It folds its webbed arms up and over its own body, like a cloak pulled over a head, exposing rows of fleshy spines in what is called the pineapple posture. If that does not work, it releases a cloud of bioluminescent mucus from the tips of its arms, not ink, but glowing liquid, and vanishes into the black, while the predator is left staring at light. Its blood is blue. Its eyes are proportionally among the largest of any animal on Earth. It has been drifting through the deep ocean since before the dinosaurs, unchanged, unbothered, waiting out everything. The frilled shark. Most sharks look like sharks. The frilled shark looks like the ocean decided to make a mistake. Its body is long and eel-like, reaching nearly 2 meters, and it moves through the water in slow, serpentine curves. It has 6 pairs of gill slits where almost every other shark has 5, and the first pair wrap all the way around its throat, forming a frill of reddish tissue that gives the animal its name. Its mouth is filled with approximately 300 needle-like teeth arranged across multiple rows, each tooth carrying 3 sharp points designed specifically for gripping slippery things that do not want to be held. The frilled shark's lineage has remained this way for millions of years. It hunts at depths down to 1,170 meters in cold water where almost nothing else moves. No one has ever observed it feeding in the wild. What scientists do know is what it eats: squid, deep-sea fish, occasionally other sharks, because they have found the remains inside its stomach. And then there is its pregnancy. The frilled shark carries its young for up to 3.5 years before giving birth, the longest gestation period of any vertebrate ever recorded. It gives birth to between 2 and 15 pups, each already 40 to 60 centimeters long. It has been doing this in the dark, in the cold, in near silence, for longer than our species has existed. The black swallower. The black swallower is 15 to 25 centimeters long. By every visible measure, it is a small, unremarkable fish, living between 700 and 2,745 meters below the surface of tropical and subtropical oceans. Nothing about it suggests what it is capable of. And then you learn what it eats. The black swallower swallows prey up to twice its own length and 10 times its own body mass, whole. It does this with a lower jaw that extends beyond the upper jaw and hinges open at an angle that should not belong to anything that small, and a stomach that stretches around the meal like a thin elastic bag pulled over something far too large. Its teeth hook inward, recurved so that once something is in its grip, there is no pulling free. Occasionally, the ambition outpaces the biology. The black swallower sometimes swallows prey so large that the stomach cannot digest it before decomposition begins. The rotting fish produces gases inside the black swallower's body. Those gases expand. They force the fish upward, away from the crushing pressure it needs to survive, up through the water column toward the surface where the pressure drops and the stomach tears open. This is how the species was formally discovered in 1864. A dead specimen washed up off Bermuda, stomach burst, killed by its own meal. Scientists still find them this way. Even now, floating at the surface with their bodies distended, evidence of something that tried to consume more than the world would allow. The giant isopod! The giant isopod looks exactly like a common pillbug, the small gray creature you find curled under rocks in a garden, except that it can reach 50 centimeters in length and lives on the floor of the ocean between 170 and 2,040 meters below the surface. It has 14 legs, compound eyes, and a rigid segmented shell that articulates as it moves across the cold mud of the Atlantic, Pacific, and Indian Ocean floors. It scavenges whatever falls from above, the carcasses of whales, fish, squid, moving slowly through a world of near-total darkness where meals arrive without warning and then disappear for months or years at a time. The giant isopod's response to this uncertainty is to eat as much as possible when food exists and then simply wait. One captive specimen went without food for over 5 years before it died. Not 5 days, not 5 weeks, 5 years. Its metabolism slows to almost nothing, its body drawing on whatever reserves remain, patient in a way that has no human equivalent. The reason it grows so large where its relatives stay small is a phenomenon called deep-sea gigantism. At those depths, in that cold, with that pressure, something in the biology shifts and keeps growing. The ocean floor is full of creatures that followed that same rule into sizes and shapes that make no sense until you understand the world they were built for.